So the assignment is 658A, 1 through 51 odd. Okay. If I had a right triangle with a 40-degree angle, and I knew that the adjacent side was 6, and I wanted to know the hypotenuse, how would I find it? So there's my right angle. I would write the cosine. Why did I choose cosine? A and H. So the cosine of 40 is 6 over x. That's a switch. So 6 over the cosine of 40. No, we're not going to do that today. So 6 divided by the cosine of 40. Hopefully I'm in degrees. Looks like it. Okay. So that is what sine, cosine, and tangent can do for us, and a lot of other things. What if I switched it up just a little bit, and I said, here is my right triangle, and this side is 8, and this side is 15. How big is theta? Would be sine of theta is 8/15, and then we invert the sign. So basically, we switch the domain and the range, and I get sine inverse of 8/15. So the sine inverse of 8/15. Oh, I didn't do inverse, sorry. And it gives me 32.23 degrees. Okay. Before the invention of calculators, sine inverse had another name. We shortened it because the actual name doesn't fit on our calculator. And really, sine to the -1 is kind of a misnomer, because what is, if I said x to the -1, what does that equal? 1 over x. So in reality, sine to the -1 of theta is actually 1 over the sine of theta, which is the cosecant. And that's not true. When we say sine to the -1, we mean inverse sine. So we use a convention that breaks our own rules. Okay? So sine to the -1 does not mean cosecant. It means you switch the angle and the ratio. The true name of the inverse sine is called the arc sine. But arc sine doesn't fit on your calculator button. So instead, we write sine to the -1, which is actually incorrect. And mathematicians recognize it, and they say, so what? Yeah. I don't know. I'm not sure. So the negative raised to the -1, it does mean inverse. It is the inverse button, but it also means flip the fraction upside down. So it's a little bit problematic. So if I had the arc sine of 3 over 4, what does that, or let's do 3 over 5, sorry. What does that mean? Well, we draw an angle, or we draw a triangle, we call this theta, and the opposite would be 3, and the hypotenuse is 5, and we would know this is 4, but what are we actually computing? The angle. Did I need to draw the triangle to figure out what the angle was? No. All I need to do is the arc sine of 3/5. Oh, I missed it again. And I get 36.86. Okay. What if I did this? The arc cosine of 1/2. I don't need a calculator. So cosine is the x value, right? So which of these 3 points has an x value of 1/2? Look at your unit circle. It's 60 degrees. Okay? Now this is a little bit weird. Are there any other angles that have an arc cosine of 1/2? 300 is the same. And then you could do coterminal angles. You could say negative 300, or you could say 360 plus 60 is 420. So whenever we do arc, cosine, sine, tangent, any of those, almost always we're looking in quadrant 1. Okay? Because in reality, there are an infinite number of answers. So almost always we're looking in quadrant 1. Okay? So what is the arc tangent of 1? Pi over 4 or 45 degrees. Right? In order for the tangent to be 1, the sine and the cosine, or the y and the x, have to be the same value. Okay? What about the arc tangent of the square root of 3? So if I did the 30-degree angle, then I get root 3 over 2 comma 1/2. And how do you divide the tangent? It's y over x. So 1/2 divided by root 3 over 2. Flip that upside down and I get 2 over root 3. 1 over root 3, so that's root 3 over 3. That's not what I wanted. Oh, I did pi over 6. I'm sorry. You were right. So I've just come accustomed to ignoring you. So how about pi over 3? So it would be root 3 over 2 divided by 1/2. So I times it by 2 over 1, and those cancel. So it is pi over 3, or 60 degrees. What does it say? Yeah, the first one is radians, the next one is degrees. Okay. Now, what about negative angles? So what about the secant of -2? Well, I don't like the secant, so I'm going to change it to, arc secant. I'm going to change it to the arc cosine of -1/2. Now that will not be found in quadrant 1. So it could be in 2 or it could be in 3. So I bet the answers are going to be in 2, because usually when you're doing this, you're building a triangle. And if the answer was negative, or was 240, what's wrong with 240 degrees? It doesn't fit in a triangle. So you can actually have a triangle that has a 120-degree angle, but not a 240-degree angle. So in that case, it's going to be in quadrant 2. Yeah. And with the sine value, are there any signs that have a negative attached to it? Yeah, some of them say arc and some of them don't. Um, so number so in 8, so 8's a little bit different. So 8 has a -1. Where is the arc cosecant -1? be -1, so the answer would be 270. Okay, and that one doesn't really have another option. That's kind of the only place it can land. So I don't think you'll see any negative signs other than 270. So, and I'm not sure, you know, I've never done this assignment before, so I don't know exactly what Cynthia's going to say, but there are multiple answers, and you guys understand that. So that takes you all the way through 31, and then 33 to 52 is easy. Use a calculator to evaluate each expression, give the answers in degrees, and round it to 2 decimals. Okay, so you're just going to type it in. And then for 43 to 51, give the answer in radians and round to 2 decimals. So you'll just switch your calculator to radians, and then the answer will be a decimal that won't have pi on it. So, and actually, never mind. We're going to stop. We're only going to go, there's no sense in doing the radians. So we'll stop at 41. Because a radian without a pi on it doesn't really help. That's just a complicated number. Yes, Jimmy? Oh. Okay. Get to work.